So topic 1.2, which is related to the motion, and you can also use your mic or you can use a chat or screen annotation to answer the question while I'm discussing. I'll discuss each question and I will give you time to answer as well. So topic 1.2, motion MCQs, the speed time graph represent a journey, as you can see. So speed time graph, as we know, area under the graph will give us the distance travel. Whenever we have a speed time graph, area under the graph shows a distance travel. So as you can see, we have two regions, X and Y. The region X is having a large area as compared to that of region Y. So what this indicates, how does the graph shows the distance travel in section X is greater than distance. So for a speed time graph, whenever we have a speed time graph, the distance travel is given by the area under the graph. So the area of X is more than area of Y. That's why the distance covered in X is more than Y. That's why option A is the right answer. The area below X is greater than the area below Y. If it was about the acceleration, like which is having a greater acceleration, in that case, we compare the gradient. The greater the gradient, the steeper the gradient, greater the acceleration. The next is a car is traveling at a velocity of 2 meters per second. So that's a starting velocity U. It accelerates at a constant acceleration of 0.2 for 2.5 minutes. Whenever a time is given in minutes, always convert into second. So 2.5 minutes, how many seconds will be there? What we have to do? We have to multiply by 60. So when we multiply by 60, so 2.5 into 60, that will be 150 seconds. We need the final velocity of the car. So we have the formula that acceleration is the change in the velocity, the final velocity minus initial velocity divided by time. Then we just substitute the values. The acceleration is 0.2, 0.2. The final velocity, we don't know. The initial velocity is 2. And the time is not 2.5 minutes. It should always be in second. So the time is 150. So this 150 is divided. Other side, it will be multiplied. So 0.2 multiplied by 150 is V minus 2. 0.2 into 150, that makes 30. 30 is V minus 2. 2 is subtracted, other side will be added, so 30 plus 2. So 30 plus 2, that makes 32. That's why D is the right answer for this question. Is it clear, this one?
Yes, sir.
Yes.
Okay. The diagram shows a distance time graph for 4 objects, which graph shows an object moving with the increasing speed. So distance time graph, the slope represents the speed of an object. So when we compare, here it's a horizontal line. So if it's a horizontal line, what does it mean for a distance time graph? The distance is not changing, means the object is at rest. If it's a constant gradient, a constant slope, it means this object is having a constant speed. Here the slope is decreasing. So what it shows the speed is decreasing or it is decelerating, and the slope is increasing. So it means the speed is increasing. For a distance time graph, the gradient represents the speed, and for velocity or speed time graph, it represents the acceleration. So we need for increasing speed. So that's why D, we select D as the right option. The next is in question 4, a ball hits a bat with a velocity of 30 and leave the bat at a velocity of 20 in opposite direction. Remember, velocity is a vector quantity. So if the direction change, we have to take a different sign. That's how we represent. So the ball hits the bat. So this is representing a bat. So it hits the bat with a velocity of 30. But when it leaves the bat, it leaves the velocity of 20. and it was in contact for 0.1 second. We need the acceleration. So if initial we take negative, the final will take as positive. And it's up to you. You can take initial as positive, the final will be negative. It won't make difference to the magnitude. Only the sign will change, but the magnitude remain the same. So we have the formula that acceleration is a change in the velocity divided by time. So when we use the formula that acceleration is the change in velocity divided by time, so the final velocity is 20 minus the initial velocity is minus 30 and divided by time, it's already given in seconds, so we don't have to convert unit. So 20 minus minus negative negative, it will be positive. So 20 plus 30 divided by 0.1. And 20 plus 30 is 50 divided by, so it will be 5,000 meter per second square. And simple way you remember, whenever you're calculating a change in the vector quantity, like change in momentum, if you remember the topic change, when we were calculating a change in momentum, if the direction changes, we add the two. If the direction does not change, we subtract. Same thing happened here. As you can see, the direction has changed. So if you are calculating a change, we will add them. If the direction of the vector quantity does not change, to calculate the change, we will subtract them. Is it clear, this one? Any doubt in this?
No. Sir, clear.
Okay. Then in question 5, a train begins a journey from a station and travels 60 kilometers in 20 minutes. Look, all the options are in meter per second, so we have to convert the distance from kilometer into meter. If I want to convert the kilometer into meter, what we have to do? We want to convert the kilometer into meter.
Multiply 1,000.
We will multiply by 1,000. So 60 multiplied by 1,000 means 60,000 meters. Time is in minutes. We have to convert it to second. So we'll multiply by 60. So 20 multiplied by 60, 1,200 seconds. If we need the average speed is the total distance over total time. So total distance is 60,000 and total time is 1,200. So when we simplify this, 60,000 divided by 1,200, so we'll get that as 50 meter per second.